Hi, I'm Tim Skornia. I've had the pleasure of being the Mountmaker here at the St. Louis Art Museum for the past 7 years. I'd love to show you around. Come follow me. After all that, welcome to the Mountain Lab. Since I'm the only Mountmaker here at the St. Louis Art Museum, I'm going to go ahead and take this down so you can see my wonderful face. I am going to talk about a couple different things. I'm going to talk about some storage solutions. I'm going to talk about different tool ideas that I've implemented since I've been here. I'm going to talk to you about some techniques that I've used as far as making mounts in the lab. I think it'll be fun. So let's have a look. This is my clean space. I've got my work table here with double monitors for my CAD drawings. I've got storage, jeweler's table, more chemical storage, large work table for mounts for larger objects. A couple mounts here. I've got more storage up here. I've got a mobile cabinet for art storage itself, for objects. Keep all my brass out here. I keep it in the clean space away from the steel and away from all that debris so I don't get cross-contamination. One of the first things I did was implement this helmet so that it's just a safer helmet. It's self-exhaust helmet. This is the steel room. So this is my steel shop. Got a soldering station here. This is all my welding area, plasma cutting, anvil. And then this is my finishing area over here. Got your sandblast cabinet, drill. You got a micro mill. And then I'd like to just kind of break it down segment by segment. We're going to start with the TIG. So the Dynasty 350 is the TIG welder that I have in here. It's a great tool. It can do more than I would ever need here. It's great for when I have to stick weld and I can pump it up all the way. For the most part, when I'm TIG welding, I only go max at about 200 amps. But it does have quite a lot of features. Mostly I weld on a pulse setting because I'm mostly doing mild steel. The pulser is great for mild steel. The type of torch I like to use a W250. It's a great little torch. It's kind of like a mid-range torch. You can get up to about 200 amps with this thing. I like to use a gas lens. Gas lens gives me a nice, steady, even purge on the metal, and I really like this torch. It makes it so that because this machine can put out a lot of amperage, but with this little torch I can weld at about 4 amps. That can weld like 30 gauge steel, which is like hair follicle thickness. So it's a pretty exceptional little torch. And then with that, I always use an aluminum plate as a heat sink. I don't weld directly on my steel table, mainly because I don't want to fuse to my steel. So I always use a sacrificial metal, which I prefer aluminum. Some people use copper. I like aluminum. One thing I'd like to talk about is this cool gel. For Mountmakers, this is magic. If you ever have to rework a mount, take it out of the gallery, and you need to rebend something, or it just needs a little tweak here or there, and without having to sandblast all the paint off, this stuff, you spray it on. Okay, you're gonna want to remove it with like denatured alcohol after the fact, but you spray this stuff on and it'll absorb that heat within the gel, and then you can wipe that gel off. And it's not harmful for you. I mean, I wouldn't drink the stuff, but it's a good little product. And then I'd like to talk about this tungsten that I like to use. So I'll have my wonderful wife and assistant help me out. So what I prefer to use is lanthanated tungsten. Lanthanated, to me, really is ideal. You can weld aluminum, stainless, titanium, really whatever type of metal you want to weld, and the stuff is not radioactive. So I prefer that over any other tungsten. So my table is set up at about 36 inches, right on it. So what I've done to help myself out in the shop is I've taken a piece of square tubing. I set square tubing on my anvil, knock it in, and that's 36 inches. So I can weld larger parts right here. I don't have to bring in another table or bring in any other prop tools to keep parts up while I'm welding. Again, it's very easy, simple. All right, so this is my little annealing furnace that I built. It's just out of leftover fire brick, fairly inexpensive. It was all sitting around just waiting. These are the inserts that I'm talking about, just steel inserts. For me, when I use steel inserts for larger mounts, I have to anneal them. If I'm making them out of aluminum, I don't have to do that, or if I'm making them out of brass. But for this purpose in particular, I have to anneal them. So I built this little bitty furnace so that I could soften parts. It also works on smaller mounts as well. But it gets me to a pretty even heat. So I'm going to show you how it works, and that's it. I just slide this in through that little sleeve. It only takes about 3 to 5 minutes to get your parts up to temp to be annealed in this small furnace. It takes about 15 minutes for the parts to cool completely. I would let your parts cool to room temperature before handling, obviously, and before you turn them on the lathe. I would never suggest chilling any parts, especially steel. Turn it on the lathe. So now I'd like to talk about my plasma cutting station. Here's my plasma cutting station. I made it so it anchors to the wall, and it's on a hinge. So if I need to at any time, I can always kick these legs out, slide it down, and then I can do larger parts. I can also move my vise out of the way, and I've got a little clamping setup for my anvil that I can do large pieces over here. But I have my exhaust hood right over it, so I can exhaust all the fumes. My little plasma. And this thing can cut up to 3/8 steel, so it's pretty good for such a small machine. And then my air, I can just hook up directly, so I don't have to keep it connected at all times. And then with that, over here, since this is kind of my cutting area, I have all my my angle grinders all mounted. So I built this little mount system. So all these little flanges, I turned this little piece on the lathe, right? And then made these little flanges and milled them out. So then you can slide these in and out. If you don't need them, you don't need them, but you can put them in and then they'll hold your grinder in place, and then everything's tucked out of the way. And then you got all your abrasives up top. So it just keeps everything organized, clean, out of the way, but then at least I have everything very accessible at any time. So now I'll talk about the anvil. So underneath my plasma table, I keep my swag block if I need to do any doming, shaping for contours. So I don't use it very often. I usually keep a steel plate on top of it so that I don't get sparks and slag inside of it and I don't have to clean it. But I keep it underneath here in case I ever need it. So here we have an English anvil. This was here before I got here, but it is an excellent tool. One of my predecessors brought it in. He was a very good blacksmith himself. One of the first things any blacksmith, any metalsmith should implement into their tools is a holdfast. This is a great tool for mount making. Then you have all your tongs, hammers, rivet tools. If you have the ability to make your own tools, that's great. So, you know, for me, I needed some flat jaw tongs, a couple different sizes, so I can make them myself. Having that ability is really great, a good asset. Also, bringing in other hardy tools. So this is one of my hardy tools that I use when making my. Just slides in like that, and it's a flatter tool. So if I need to flatten out metal, stretch metal, I'll show you an example. So it sets in, it's locked in place, it's spring loaded, and then I also have these different hole patterns here so I can move it up or down, so I can put in larger stock if I need to. This is a great tool for, say, if you have to join two pieces of brass, 2 pieces of steel, whatever you need to do to make flat, even joints. So, you know, I would hammer this out, hammer that out, and then I can also hammer on my table here, right there. Then I can get 2 nice little joints for when I'm soldering or if I'm welding. So it's a great little tool, and it's also great for stretching out material also. So as you can see, it's a flat each time. So it's basically for stretching steel, stretching brass. Now I'd like to show you another little jig that I made for a sander. If one of your sanders goes down, it's a small little handheld jig that you can put in a vise. So from here, it's just a flange that's welded to a flat plate, and then all I did, I just cut, I just cut with the bandsaw. I cut out in the middle, drilled a hole, cut out in the middle, re-welded the seam. That was it. Put some blue tape on top. Now it's a flat little deck. Clamp it in, plug it, you're ready to go. And then it really helps out if you need to do a lot of tungsten grinding, or if one of your sanders is down. This is an excellent tool. Or if you just you got a small shop and you can't fit a sander in your shop, this is a great little jig to help you out. So here is another little jig that I made. It's a wall hanging clip from the wall for 2D work. So it slides inside of this little box. It's got welded sides, fusion welds, and then from the bottom I can do a fusion weld underneath, and that's it. With this little jig, I can make about 50 wall hanging clips in an hour, and this little component here will slide back, and I can put in larger or smaller clips if needed. It's a great little universal jig for wall hanging clamps. So I thought that was pretty interesting. So here we are over at a sander, my ball door. This guy's great. He's got scotch pad on one side for buffing. So I use this primarily only on mounts. This I only use for tungsten and sanding drill bits. That is it. It's really just my tungsten side. You don't really want to use a buffing wheel on tungsten itself. You want to have those granulars for your electrode to be able to pass through. So buffing them out is not ideal. And with that, I thought it could be important to show you how to sharpen a drill bit. So what I do is I set my pitch to about 60 degrees. I set my table to 60 degrees, and then I write a line on the said table at 60 degrees. And all I got to do is stick my flute up against the side and do about a 1/16 of an inch twist. And twist, and twist. I flip it to the other side, and I twist, and then I can do my reliefs right on the side of the wheel, just hit it once, hit it twice, and that's a bit I've sharpened. So it's pretty sharp, but then you can at least sharpen your bits and you don't have to send them in to be sharpened repeatedly or buy new bits all the time. And this method works great on really anything from about 3/16 and up to 1/2 inch or beyond. Anything smaller than that, yeah, you're gonna wanna either take a file and do it by hand, or you're just gonna wanna use sandpaper. So I thought that was interesting. So this is my little Grizzly 4-inch micro lathe. Pretty small, but they can turn out some work. So here is some inserts. Here's a brass insert. Here's an aluminum insert. Steel inserts are a little tough on these guys, but they can do it. They just need to be annealed. It is a great little tool to have. I love it. Again, I build a lot of storage brackets. This holds all my hardy hole tools. So I just got a bunch of different hardy tools, as well as I built this other bracket that holds all my clamps, keeps them up out of the way. So here's some more storage solutions for you. Keep all my jeweler's pliers and my taps. These are the most common that I use, 256 to 1/4-20. Measuring equipment. Keep my jeweler bench fairly clean, a little light, a vise. That vise is mainly to hold parts or to hold my little Dremel here, my Dremel tool, so I can fix it into the vise and work on parts. And then within each drawer, very clean, organized. Files, more files, some abrasives. You get the point. And I also keep another tap set. I also have more and more taps, any tap size you want, metric or standard. More storage. It's all my brass. Keep everything out here, tucked away clean. It's all my filler rod, aluminum, stainless, nickel, bronze. All back there. Again, that's all off-fall, leftover material. More brass. This whole chest here is also filled with brass, mostly sheet plates and other common clip type mounts that I use repeatedly. You see, I make all of our hanging clips too for textile, and I just make a variety of them, keep them all ready. A bunch of magnet mounts, steel plates are already painted as well as lined. I just keep them all in here. Easy for an installer to grab, or me to grab, anybody who wants to grab a couple mounts real quick. More storage. More storage, off-fall, just some square stock. I don't use a whole lot of square stock anymore. This is a mount wall. It's 3/4 inch plywood, which is what we use in the gallery, so I can test everything before it goes out. Hanging for drying mounts. After I take them to the paint booth down the hall. We have a paint booth down the hall. I spray everything down there. I don't do much in the lab anymore, if any. I spray it, bring it back down here, let it cure overnight. So here's a sculpture of Othello. It is a stone and bronze bust. And this piece will receive a mount in the near future, coming up later this year. I just wanted to show you all what the process is for making a mount here at the St. Louis Art Museum from start to finish. So It starts with an idea. That idea is talked about with conservation, curatorial, and design. And from that, I create a drawing of the mount in its entirety with all its components so that everyone can see exactly what's going to happen. Then, after that mount is carried out and everything is successful, I then take that drawing and all the images of the mounts themselves and I store them in TMS for future mount makers. If the object is to go out on loan, it just simplifies it for everyone involved and creates documentation, which is very important, I think, for our field going forward. So. Okay, so I just want to talk briefly about just some mounts that I have in the lab for objects that are being ready to be installed. So this is just an acrylic mount. This is all hand sanded. So, well, first I took it to the sander, sanded it down, got a nice beveled edge, and then I went through starting at 60, moving my way down to 6,000 grit to get it to be see-through, clear. I'm sure any acrylic mount maker knows what I'm talking about. They take a long time to do, but they do come out successful. So this is an insert, a deck insert that is flipped upside down, and then I can adjust each side. So if my hole is a little sloppy, then I can at least adjust and straighten out the post underneath the deck. So that's those acrylic mounts. Here are a couple knife mounts. So these are knife sheath mounts. These are for Native American. And what I use is a 256 set screw, very small, but I use a little bit of turquoise in there. You can see it to help installation, the installer be able to set that. This is your locking pin here on either side, your locking prong. So that's a set. So this is just one case. That'll be another installation. Okay, so here's another piece that's going in later on, early next year for Oceanic Australian. This piece is a full contour mount, and the curator wanted to be able to see it in the round. And again, this is just what I have in the lab right now. I didn't want to go out into the galleries, but it's a full contour, and then I have my setting prongs, one here, so that I can sleeve it in, lock it in place. Here's another contour mount. It's fairly thin gauge steel. I get to keep it pretty thin gauge because I use this gusset. So this is pretty thin, 1/16. It's only seen from one direction, so it's not that visible. But with this, what helps with the plasma cutter is I can go in and build my template with cardboard, trace it right up to the object, transfer that over into steel, and just zip that out with the plasma cutter, tie in with another 1/16 thickness plate, steel sheet, and tack weld in, hammer it down, and then that gets me flush up to the object itself, so I have a wider contact range, and that's it. All right, so next I wanted to talk about a couple of these prototypes. This was my first prototype. This is the second version of the same, but these are wall-mounted isolation units. They're still in early stages, but I've been working on them. Whenever I get a chance, I work on them. But where we're located in St. Louis, we're close to the New Madrid Fault. Other cities like Memphis are pretty close. But everything at the St. Louis Art Museum is spec'd to accept at least a half a G of force, if not 1 G of force, depending on the size and its center of gravity. So for these are little, they're for plate mounts, so fairly expensive. A lot of plates we have in our collection, ceramics, are very expensive. So one day, the hope is that you would be able to fasten into these two holes. So I would make a template of just those two holes, and all my plate mounts would sync up to this. If I could get that down, sandwich this in to even lose another 1/4 of an inch, it would be much more promising, because right now I have to raise it. Right now it sits at about a 1/2 of an inch, which is sits a little too far away from the wall for me. And also the dampening system, it's rated, and I've checked it time and time again, and its deflection and its kickback is pretty decent, but it still needs some more work. Once it gets to maybe its 3rd stage, where I have the inner cylinder inverted inside or inset inside of the aluminum, I would probably send it out to another engineer to try and finish it up. But that I thought was pretty cool. Whenever I get a chance, this was the first one. You can see what it's doing. It's 2 springs that work against each other. That was the first one, just to kind of show to scale. And then this is my second one. So I hope you all enjoyed your stay at the St. Louis Art Museum. My email is timothy.skornia, S-K-O-R-N-I-A, @slam.org. And I hope to see you all in St. Louis at some point in the future. Stop by the museum at any time, go to the desk, ask for Tim Skornia. I'd be happy to show you around, show you some mounts, some of the other procedures that we go through, and have a good time. Also, wear your mask, be safe out there, people. Mount up.
I'm wondering if you're ready to answer some questions.
Yes, absolutely.
Fantastic. I might start off and ask you one. Can you talk to us a little bit more about the design process? You know, the way that you used Autodesk, was that correct? And
Autodesk 360 Fusion.
Can you talk to us about that?
Huh? Okay. Yeah. It's a software program, Autodesk 360 Fusion 360. I have a scaled down version. I don't have all the extra amenities that some of them have, but for doing 2D drawings, it's ideal. And it just makes it easier for me to break down all the different components to then send out to another machine shop if they're going to do that work. So.
Thank you. Fantastic. And how about a little bit more about your problem solving process? You know, the design of it and what you were trying, like what was the problem you were trying to solve, and then how did you come to that solution?
Yeah. So what was going on with these jug boxes is the way that the panels are joined. There's most likely like a dowel system that's within them, like a dowel rod, dowel pin system that's press fit in, and they are most likely adhered with an adhesive. So we were having an issue with, we thought it might buckle while it was being transported across the country. And I came up, we talked through a lot of different solutions, like building an entire cage that surrounded the entire piece, but all those different ideas would require somebody to have to step inside of the piece or along the outside, and it could allow for damage. So doing a simple right angle clamp was the best solution I could come up with.
Fantastic. Thank you. That's wonderful. Can you talk to us a little bit about the, there's a question here and it's saying, was that milled on a metal lathe? I guess they're asking about the manufacturing process.
Yeah, so all that should have been, that was probably done on a Bridgeport. So yeah, it would be on a stand-up mill machine. I was a machinist in the past before I was a mount maker. So I knew a little bit about how to do technical drawings like that to make it pretty easy for them to transfer over into their file. So yeah, that was most likely done on a mill, not on a lathe.
Thank you. There's another question here that says, have the Judd Foundation or other institutions with similar pieces adopted this method?
I'm not sure. I don't think so. I mean, I was not in contact with the Judd Foundation. I didn't want to go through that process of contacting the Judd Foundation to find out if I could use these images. That's why I drew everything out. So I am not sure. But we own that particular piece, so that's why I was able to do what I did. But as far as image rights, I can't reuse those images and try and get any kind of, I can't, I can't use them myself.
Yep. Another question has just come through. It says, did you have to work closely with the Judd studio to develop the brackets?
No. I did not. I did not work closely with the Judd Foundation or the Judd Studio at all. I worked closely with the other museum that the objects were going to, and we compromised with the solution that could get the Judd boxes there, because we were afraid of shipping them across. They were going to New York, so we wanted to make sure that they were safe all the way up to the Northeast from St. Louis.
And so did you do an evaluation of how well they worked? I guess before I ask somebody else's question, I just wanted to understand, was there an evaluation done of how good this method worked?
Yes. Yeah. So I evaluated. Yeah. I mean, I did a test fit and I went through and I checked the overall consistency of each component. I had to mess around with how it was threaded. There was some press fit, stainless steel press fit fittings that work to hold in the threaded rod so that it can't twist side to side. So yeah, I played with it quite a while to make sure that everything worked seamlessly.
And even after they were used, like it all just worked well after it was used and there was positive feedback?
Yes. So they made it to New York and it was successful. And I heard that everything went really smooth and they will be returning in the next 2 months. So they will be coming back. That's a fairly recent project.
Fantastic. So there's a question here about so the Teflon for vibration, was it used for dampening or was it used for contact issues?
Not for dampening, for contact issues. Are you talking about the Teflon?
Yeah.
Yeah. So the Teflon, yeah, that's for friction. So the dampening system, yeah, there's not really a dampening system within that. But yeah, that's more for friction against the acrylic. So it acted as a secondary barrier in between the LDPE.
Thank you. There's another question here that says, what kind of documentation did you send along with the object about the supports? Did a courier go with the shipment?
Yes, our objects conservators went with the piece itself. And yeah, it had full documentation, an entire breakdown of how to assemble, take them apart. If anything fails, I sent some special tools to take things apart.
Thank you. Another question has come through. It said, did you choose to fabricate new clamps instead of retrofit a standard right angle to save space, or for another reason?
It was the scale. So I tried to get, the ratio wasn't correct. I needed to be able to span a certain amount of square footage of the piece to accommodate how heavy it is. Each one was around 400 pounds. So they needed to, a normal right angle clamp, I think on average is about 3 to 4 inches in length. These are 10 to 12 inches in length. So wow. It's double the size.
Yep. Another question is around sort of lifting. So did you have to lift the cubes to place the braces on the corners on the floor side of the cubes? Yes. Did you have eight preps hold it while those braces were placed?
No, we used ethafoam. We used padding to put underneath them. And then that's how we got the bottom braces on. Sorry if I didn't show that in the slide, but yeah.
In a follow-up to that, someone's asking, could there be an alternative way to move these without needing 8 art handlers? The pallets are difficult to slide away with that many people.
Yeah, I mean, you could build a secondary skid and you could shim the sides potentially, but again, I wouldn't try to shim this because of how it's assembled. It's all adhered together. So if you tried to rig it in a way where you would put shims underneath to get straps underneath it, I think you could jeopardize those joints. So I would imagine, yeah, you need 4 art handlers, not 8. So it's 2 to a side, so 4 each to place it.
Yep, thank you. And there's another question about how did you judge how tight to clamp the boxes without stressing them?
That's a good question. So yeah, I played with that quite a bit with the LDPE and its density. So yeah, I mean, how that right angle clamp opens up, it opens its max capacity is just to fit over the threshold of the piece. It's just to fit. It's a very snug fit. And then you just have to tighten it maybe 2 turns to get it to lock. I didn't want to make it over big, so then I would have all this excess threaded rod sticking out. So yeah, I played with that quite a bit also. So I just took into account the thickness of the aluminum, the acrylic, as well as my LDPE and my aluminum plate itself, added all that together and added in about 1/16 of play. So they're very snug fit. You can't really use them for framing. They're specifically designed for just those boxes.
Okay, great, thank you. And then there's some questions here that are related about how much time did the whole project take? And, you know, so how long did it take to develop the solution, and just sort of how much time did they take to machine? So lots of time questions.
Yep. So around 6 months, we started talking about how to develop an idea. We had a couple meetings, and then I did a couple preliminary drawings for approvals. Everything I do at the museum goes through an approval process anyways, and that all is stored in TMS so anybody can see it. But yeah, so the approval process, once that's agreed upon, then again, we had to have where the objects were being sent to. They agreed upon paying for some of this stuff. And then after that, I put together the drawings, and then those were sent out. And then once they hit the machine shop, it doesn't take long to do those CAD drawings, maybe a week. And then once they approved everything from their end, and they take those drawings and it's in a PDF format so they can readjust anything that they need to for their particular CAD program or other system that they use. And so all in all, about 6 months.
Wow. Thanks so much, Tim. That's all the questions for now. So thank you.